All right, section 5.5, differentials in Newton's method. I've completed the examples that we did not get to do in class. So you can watch this video and you can pause to see how they are completed. Example 8, changing tires, inflating a bicycle tire, changes the radius from 12 to 13 inches. Use differentials. So that's key for the way we need to go about this problem. To estimate the absolute change, the relative change, and the percentage change in perimeter of the tire. So what I have here is perimeter of the tire is circumference, 2 pi r. Original radius is 12. The differential in radius is 1. So to use differentials to estimate the absolute change, we are going to use dc to approximate the change in the circumference. So I took the derivative of circumference and wrote it in differential form. So dc equals 2 pi dr. Plug in 1 for dr, we have dc equals 2 pi. Then to do relative change, you take the dc that we got in the first part and put it over the original c, the original circumference. So we have 2 pi over 2 pi r, where r is 12. And we get 1/12 for the relative change. And then the percent change, we take the relative change that we just calculated, 1/12, and we multiply it by 100 to get a percentage, 8.3% change. All right, example 10, determining tolerance. About how accurately should we measure the radius of r, the radius r of a sphere to calculate the surface area, S, equals 4 pi r squared within 1% of its true value. So we are looking for the differential in r, or some guidance on what our differential in r would need to be, given that our percent change is 1%. So I worked backwards from percent change. 1 equals ds over s times 100. Divide by the 100, and we have 0.01 equals ds over s. ds is going to be the derivative of the surface area equation written in differential form. So ds is equal to 8 pi r dr. Surface area is 4 pi r squared, and we simplify and solve for our dr. So we have 0.01 equals 2 dr over r. Multiply both sides by r and divide by 2. We get dr equals 0.005 r, which means we should measure within error or have our error be no less than 0.5%. And then finally, the Newton's method example that we did in class, I just wanted to show the work for. We take an initial guess in the region where we know the root is, between 0 and -1, so I guessed -0.2. And then we use our formula to find x sub n plus 1, and that is x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. And this just comes from the point slope equation of the tangent line when y is 0. And my hint for you was to put the f of x sub n over f prime of x sub n in your y1 on your calculator. And then it just makes it easy to do this iterative process. So to get x sub 2, we'll take x sub 1, which is -0.2, minus y1 of -0.2. So if we've put this in y1, then we can evaluate that at -0.2 to help us calculate our x sub 2, which is -0.3256. Then we can use x sub 2 to help us find x sub 3. Same calculations. And we get -0.32219. And I went one more to x sub 4 and got -0.32186. So I can see that we are no longer changing to 3 decimal places. So the root is at approximately -0.322. That's it. Study hard. Test on Friday will cover 5.5 and 5.6.